Okay, guys, one more example. I forgot to screenshot the directions too, but this is one of those where you're going to use multiple techniques. You are already given a 0, and in this case, I actually gave you one where you have a multiplicity of 2. So you're going to do that. You're going to use synthetic division and then other techniques, factoring, quadratic formula, depending on whatever you need to factor the entire polynomial completely. So let's start with synthetic division. So we are using synthetic division. We've got a 0 of 1/2, right? 4x to the fourth minus 28x cubed plus 61x squared. I don't know why I wrote the plus there because you don't actually need it there. I mean, you can write it if you want to. Just a plain old 61 minus 42 plus a 9. So we didn't need any placeholders at all. So we just took our coefficients. No skipsies or anything like that. So bringing down the 4, and then remember, multiply diagonally, right? Multiply diagonally, and we're going to add vertically. So multiplying diagonally, 4 times 1/2, we get a 2. Negative 28 plus 2 is going to be a negative 26. Multiplying diagonally, we are going to get a negative 13. 61 plus a negative 13 should give me a 48. Multiplying diagonally, we get a 24. Negative 42 plus a 24 should give me a negative 18. And again, multiplying diagonally, we get a negative 9 there, and adding vertically, we get a 0. And that's what we would expect to get because we already knew that 1/2 was a 0. Ooh, I didn't mean to completely cover up the 1/2. So when we do this, because it is a multiplicity of 2, right? And remember, multiplicity means it comes, and multiplicity of 2 means it comes down and touches the graph or the axis and then turns around. That's a terrible drawing over there, but that's all you're going to get at this point. So it means we can divide twice, right? And if we stop and think, this top row was x to the fourth. This row would be x to the third. Depending on what this is, we may or may not be able to kind of factor this into something like factor by grouping, or maybe there's an x, like we're actually not going to be able to factor out an x because we got to, nope, we could have maybe factored out an x. So yeah, because it would have been x cubed, x squared, nope, x cubed, x squared, and then x. This would have been a constant. So you're not going to be able to do anything right now. And the best thing is, again, you know that this is a multiplicity of 2. You know you can divide twice. So continuing on, you don't have to write a new problem. You are literally just going from the same line. So bring down the 4. It's just a coincidence that it happens. No, it's not a coincidence. It happens to be the same. Of course it's going to be the same. It's now like 10:10, and I'm making these videos for you guys, so I'm kind of done. 1/2 times 4 when I multiply diagonally is going to give me 2. I get a negative 24 here. When I do 1/2 times a negative 24, I will get a negative 12, right? When I add vertically, I get a positive 36. When I do 1/2 of 36, I get a positive 18. And then I get a lovely 0. Again, totally expecting that. So I'm going to shrink so I have some more space. So what I can do now is this line right here is actually an x squared line, because this one was to the fourth, this one right here was to the third. So now I can actually take 4x squared minus 24x plus 36 and set it equal to 0. Before I do anything else, I'm going to factor out a 4. Now do not divide everything by 4. Don't divide everything by 4. I know that we're really tempted to do that, but the reason is we are trying to factor a polynomial, and we can't get rid, I'm not just trying to find the zeros, guys. I'm trying to factor a polynomial, and that is different. Okay, so by factoring, the 4 has to stick with me throughout the rest of the problem. So this is going to be x squared minus a 6x plus a 9 equals a 0. Well, this is a nice one because, remember, 4 stays with me because I'm not looking for the zeros themselves. I'm just looking to actually factor it. And you really don't even need these because you're not going to solve it. You're just factoring. So x, yeah, let me scribble them so they don't look like extra x's. Two numbers, when I multiply them, I get a positive 9, and I add them, I get a negative 6. That's not a 31. That's a parentheses. X minus 3 and x minus 3. So what you have here, okay, is you have this section right here is part of the factoring. But remember, you actually had these two up here that were already zeros. So what you do is x equals 1/2. You know that that works, right? So then you can, there's different schools of thought. I don't like to leave it as a fraction. So what you end up doing is, like you guys might just think to do, oh, subtract 1/2, which would be totally okay, except that's not really how you're supposed to leave it. So what you can do is if you take that and multiply everything by a 2 to get rid of this fraction here, okay? So when you do that, you get a 2x minus 1, although I'm wondering if that's, no, it shouldn't matter. Sorry, again, it's after 10 o'clock. 2x minus 1, right? So that's a factor, and that's a factor twice. Okay? So when you do this, you've got 4 times x minus 3 squared, and then you can have a 2x minus 1 squared. This is actually a problem from your book, and when you, if you look, it's like number 37, I think, from section 3.2. If you look at your book, it will tell you that you should leave, oopsies, sorry, you should leave, oops, minus 3 squared. You should leave it as an x minus 1/2. But again, not, you want to know why? I think I know why. Because if we put that 2 there, it's going to change when we multiply everything out. It'll change our leading coefficient. It changes the leading coefficient. So forget what I said there. Leave it this way. That's fine. You would prefer to do it that way anyway, because that one's actually easier for you guys. Okay? Again, sorry for the rambling, but you know, now you have videos for every type of problem that you got to do.